Welcome all. I am Maria Vincent, Assistant Professor, Department of Electronics and Communication Engineering, Rajagiri School of Engineering and Technology. Today I will be discussing on the topic Amplitude Modulation, which comes under the course Electronics Communication for S7 EE students. So in the previous lecture we already discussed what is modulation, what is the need for modulation, and different types of analog modulation technique. So in this lecture we are going to detailing the concept amplitude modulation, or we can say AM. The amplitude modulation can be defined as the process of changing the amplitude of a relatively high frequency carrier signal in proportion with the instantaneous value of the modulating signal. So thus modulating signal is also known as the information signal or message signal. The amplitude modulation is having two inputs and one output. So one input is a single high frequency carrier signal of constant amplitude, and the second input is comprised of relatively low frequency information signal. And this carrier signal is always sinusoidal signal, that is it is a time varying signal, and this carrier signal can be mathematically described as EC of t is equal to EC into cos 2 pi fct plus 5c, where this EC represents the amplitude of the carrier signal, fc is the frequency, and 5c is the phase of the carrier signal. So already told it is a time varying signal, that is why this t. So the parameters that can be modulated are the amplitude, the frequency, and the phase. So in case of amplitude modulation, we are changing the amplitude of this carrier signal in proportion with the instantaneous value of the modulating signal or message signal. So this figure shows how an AM waveform is produced when a single frequency modulating signal acts on a high frequency carrier signal. So the output contains all the frequencies that make the AM signal and is used to transport this information through the system. So therefore this shape of this modulated wave is called the AM envelope. Note that with no modulating signal, the output of this AM modulated signal is simply the carrier signal. However, when a modulating signal is applied, the amplitude of this AM envelope varies in accordance with the modulating signal. Note that this repetition rate of this AM envelope is depend upon the frequency of this modulating signal, and the shape of this AM envelope is depend upon, or it is identical to the shape of the modulating signal. In case of amplitude modulation, a voltage proportional to the message signal or modulating signal is added to the carrier amplitude. So let the added component of voltage is Em of t. Then the modulated carrier wave is given by Ec of t equals Ec plus Em of t into cos 2 pi fct plus 5c. So already told, in case of amplitude modulation, a voltage proportional to the modulating signal is added to the amplitude of the carrier signal. So this Ec plus Em of t, this term describes the envelope of this modulated signal. So next we will discuss what is amplitude modulation index or coefficient of modulation or percent of modulation. So the coefficient of modulation is a term which is used to describe the amount of amplitude change present in an AM waveform. and this percent modulation is simply the coefficient of modulation which can be stated as a percentage. So mathematically this modulation coefficient can be described as M is equal to Em by Ec, where Em represents the amplitude of the modulating signal and Ec represents the amplitude of the carrier signal. So this value of M is varies from 0 to 1, and this percent modulation, already told, it is simply the coefficient of modulation which is described as percentage. So capital M is equal to Em by Ec into 100. So this figure shows the AM modulated signal, and this envelope of this AM modulated signal is depend upon the shape of this modulating signal. Next we want to derive a relationship between Em, Ec and modulation index, that is M. So before going to that, we first of all we want to know what is this Vm max and Vm minimum. So Vmin represents V minimum and Vm max represents V max. So the V max is the maximum peak voltage of this AM modulated signal, and V minimum represents the minimum peak voltage of the AM modulated signal. So on the x axis we are having T, and from this point till here we are having the carrier amplitude, that is Ec, and here we draw one more reference point. So with respect to this reference point till here we are having the amplitude of the modulating signal, that is Em. So already told the AM the envelope of this AM modulated signal is depend upon what? This shape of this modulating signal. So with reference to this line, the positive half cycle represents what? Plus Em, and this negative cycle represents the minus Em. So next we'll define this Em in terms of V max and V minimum. So Em is equal to 1 by 2 into Vm max minus V minimum. So Vm max means what? The maximum peak voltage, and this represents the minimum voltage. So the Em can be defined as, that is Vm max minus this minimum peak voltage, that is V minimum, divided by 2. So this entire cycle represents what? That is 2 times Em. So we have to get only Em. So Em is equal to Vm max minus V minimum divided by 2. Similarly, Ec means what? From this point till here represents the Ec. So the Ec is equal to that is Vm max, that is Vm max plus V minimum divided by 2. That gives what? This Ec. So already know this modulation index M is equal to Em by Ec. So this Vm max, so this Vm max is equal to Ec plus Em, and V minimum is equal to, that is Ec minus Em. So this modulation index M is equal to Em by Ec. So we already described this Em and Ec in terms of V max and V minimum. If you substitute these two relation in this equation, M becomes 1 by 2 into Vm max minus V minimum divided by 1 by 2 into Vm max plus V minimum into 100. So this 1 by 2 cancels. Finally, M is equal to Vm max minus V minimum divided by Vm max plus V minimum into 100. So this represents what? The percent of modulation or the coefficient of modulation. So M is equal to what? It is the term which is used to describe the amplitude change in an AM waveform. that is m is equal to em by ec. The same modulation index or coefficient of modulation can be find out with the help of V max and V minimum, where V max represents the maximum voltage of this peak of this AM waveform, and V minimum represents the minimum peak voltage of the AM envelope. So from this waveform also it is possible to find out the value for M. So in this slide we are going to analyze the amplitude signal, modulated signal. So in the amplitude modulation we are having two input signals, that is a high frequency unmodulated carrier which can be described mathematically as EC of t is equal to EC into cos 2 pi FCT plus 5C, where EC represents the amplitude, FC frequency, and 5C represents the phase of the carrier signal. And the second input which is a low frequency message signal, which is also known as the modulating signal, which is given by EM of t is equal to EM into cos 2 pi FM into t plus 5M. So in case of amplitude modulation, a voltage proportional to this modulating signal is directly added to the amplitude of this carrier signal. So therefore the equation for the sinusoidal modulated wave is given by E of t is equal to EC plus EM of t into cos 2 pi FCT. So the term EC plus EM of t describes the envelope of the modulated signal. So we already know what is EM of t, that is EM into cos 2 pi FM into t plus 5m. So if you substitute this expression in this equation, your equation is become, your modulated wave is become EC plus EM into cos 2 pi FM into t into cos 2 pi FCT. So in both the signal we are having a term 5C and 5M. So both the signal are independent with respect to the time. So this phase is also independent to each other. So for an ease of analysis, we can make these two terms, that is 5C and 5M, as 0. So that is why in this expression we neglected these two terms. So E of t is equal to EC plus EM into cos 2 pi FM into t into cos 2 pi FCT. So if you take this EC outside from this square bracket, the expression has become 1 plus EM by EC into cos 2 pi FM into t into EC cos 2 pi FCT, where EC cos 2 pi FCT represents what? The carrier signal. So we already know the modulation index, M is equal to EM by EC. And for an ease of analysis, we have to use one trigonometric formula, that is cos A into cos B is equal to cos A plus B by 2 plus cos A minus B by 2. And if you substitute this relation to this equation, your expression has become 1 plus, where EM by E is equal to M, so M into cos 2 pi FM into t into cos 2 pi FCT. So if you use this expression, this relation, this equation has become EC into cos 2 pi FCT plus M into EC by 2 into cos 2 pi FC plus FM into t plus M into EC by 2 into cos 2 pi FC minus FM into t. So this final expression gives the AM modulated signal, which contains three different signal components. The first term represents the carrier signal, and the other two components represents the side bands. So these side bands contains what? All the informations. So these two side bands will be carried by this carrier signal. So this carrier signal is used to carry your information signal. So all the information is occupied within these two sidebands. So in this slide we are going to discuss the frequency spectrum for sinusoidal AM signal. In the previous slide we derived the expression for an AM signal which contains three signal components, a carrier and two sidebands. So in the frequency spectrum, on the x-axis you are having the frequency in hertz. So the first term, which is a carrier component with a frequency of Fc at an amplitude of Ec. So in the frequency spectrum at Fc you are having an amplitude of Ec. So the second term, which is known as the upper sideband, that is why it is Fc plus Fm. So at Fc plus Fm you are having an amplitude of m into Ec by 2. So in the frequency spectrum at Fc plus Fm you are having an amplitude of m into Ec by 2. So this second signal component represents the upper sideband. So from Fc to Fc plus Fm it is upper sideband frequency. Similarly, the third signal component which is at Fc minus Fm, that is represented as the lower sideband. So at Fc minus Fm you are having an amplitude of m into Ec by 2. So at Fc minus Fm you are having the amplitude of m into Ec by 2. So from Fc to Fc minus Fm you are having the lower sideband frequency. So in conventional AM signal is represented with the help of the three signal components, and this conventional AM signal is also known as the double sideband full carrier, means it contains the two sidebands such as the upper sideband and the lower sideband with full carrier. So this conventional AM is also known as double sideband full carrier, that is DSB-FC. So from the frequency spectrum we can easily find out the bandwidth. Normally the bandwidth can be defined as the difference between the higher frequency to the lower frequency. So from this frequency spectrum it is understood that the higher frequency is Fc plus Fm and the lower one is Fc minus Fm. So the bandwidth is equal to Fc plus Fm minus of Fc minus Fm, which is equal to 2 times Fm. So the bandwidth of an AM signal is equal to 2 times Fm, where Fm represents the frequency of the modulating signal. So in this slide we want to derive the expression for average power for the sinusoidal AM. So in the previous slide we derived the expression for an conventional AM signal which contains three signal component, that is carrier, then upper sideband and lower sideband. So all these three signal component will be responsible for the average power. So in any electrical circuit the power dissipated is equal to the voltage squared divided by the resistance, that is P is equal to V square by R. So in the spectrum it is understood that at Fc you are having the carrier amplitude as Ec. So the average power in an unmodulated carrier is given as Pc is equal to 0.707 Ec the whole square divided by 2R. We want to take it in an RMS value. So which is equal to Ec square divided by 2R. So the carrier is having an amplitude Ec at frequency Fc. So P is equal to V square by R. So the Pc is equal to Ec square divided by 2R. Similarly, both the upper and lower sideband is having amplitude of m into Ec by 2. For an upper sideband the frequency is at Fc plus Fm, and for lower it is Fc minus Fm. But both the sideband is having the same amplitude, that m into Ec by 2. So the upper sideband power and the lower sideband power is equal to m into Ec by 2 the whole square divided by 2R. We just take the RMS value. So if you solve this this expression, it has become m square EC square divided by 8R. So this R represents the load resistance. So if it is not given, we can assume the value of R as 1. So if you rewrite this equation for an ease of analysis, it has become m square by 4 into EC square by 2R, where EC square by 2R represents what? The carrier power. So this expression has become what? M square by 4 into PC. So the expression is become what? M square into PC divided by 4, where PC is equal to EC square by 2R. So the total power in an AM signal is given as PT, which is equal to the carrier power plus upper sideband power plus the lower sideband power. So the PT is equal to PC plus m square into PC by 4 plus m square into PC by 4. So in all these terms, PC is common, right? So we can take that PC outside. Before that, these two terms are same, so it is PC plus 2 times m square into PC by 4. It got the 2 and 4 got cancelled, and the expression has become PC into PC plus m square into PC by 2. In both this term contains PC as common, so we can take the PC outside. So the total transmitted power is become PC into 1 plus m square by 2, where m represents the modulation index and PC represents the carrier power. So if you know the carrier power, which is equal to EC square by 2R, and if you know the modulation index, you can find out the total transmitted power which is used in case of AM signal. Similarly, we can easily find out the AM current. So the relationship between the carrier current and the current of the modulated wave is given by PT, that is the total transmitted power divided by the carrier power, is equal to IT square into R divided by IC square into R. So in any electrical circuit, the power can be find out as I square into R. Similarly, we find out the expression as IT square into R divided by IC square into R. So both the R got cancelled, which is a load resistance. So the PT by PC is equal to IT square divided by IC square. So in the previous slide, we already derived the expression for PT, which is equal to PC into 1 plus m square by 2. So if you substitute the expression for PT in this relation, the expression has become PC into 1 plus m square by 2 divided by PC, which is equal to IT square by IC square. So both the PC got cancelled. So the expression has become IT square by IC square is equal to 1 plus m square by 2. So the IT by IC is equal to root of 1 plus m square by 2. So IT, the total transmitted current IT is equal to IC into root of 1 plus m square by 2, where IT is the total transmitted current, IC is the carrier current, then m is the modulation index or coefficient of modulation. M is equal to EM by EC. So next we want to know what is the efficiency. So in AM, the signal power depends on the sideband power. So this is the final expression of an AM modulated signal, which contains 3 signal components, that is a carrier signal, then upper sideband and the lower sideband. So this carrier signal is used to carry your information. So it doesn't contain any information. It is simply a high frequency signal which is used to carry your information. So all the information signal is occupied within these two side bands, that is upper sideband and the lower sideband. So the modulation efficiency or power efficiency in an AM is find out as eta is equal to the sideband power divided by the total transmitted power. So if you want to find out the efficiency, most of your information is occupied within these two sidebands. That is why we taken the numerator as the sideband power. So the efficiency is equal to sideband power divided by the total transmitted power. So in the previous slide we derived the expression for the sideband power, which is equal to m square into Pc by 2, and the total transmitted power is equal to Pc into 1 plus m square by 2. So if you substitute these two relation in this equation, the efficiency is become m square divided by 2 plus m square. So we already know the value of m is varies from 0 to 1. So when m is equal to 0, your efficiency is become 0, and when is equal to 1, your efficiency is become 1 plus 2 plus 1 square, which is equal to 33.33%. That is in case of an conventional AM signal, or in case of double sideband full carrier, you will have a maximum efficiency of 33.33%. So in the previous slide we discussed we derived the expression for an AM signal. Then from that we drew the frequency spectrum, and from the frequency spectrum we derived the expression for bandwidth, then the total transmitted power and the total current. So based upon that relationship we can solve some questions. So the first question is, consider the AM signal S of t is equal to 4 into cos 1800 pi t plus 10 into cos 2000 pi t plus 4 into cos 2200 pi t. Sketch the spectrum and calculate the bandwidth, the total transmitted power and efficiency. So in such a particular question, first of all we want to write the general expression of an AM signal, which contains three signal components, that is a carrier, then upper sideband and the lower sideband, which is equal to EC cos 2 pi FCT plus M into EC by 2 into cos 2 pi FC plus FM into T plus M into EC by 2 into cos 2 pi FC minus FM into T. Then you have to compare your general expression with the given signal. So in the general expression it is clear that both the sideband is having the same amplitude as M into EC by 2. So in the given signal, first of all you have to identify which is the common factor. That is, in this expression the 4 is the common one. So M into EC by 2 is equal to 4 volt. And so it is understood that this signal component represents your carrier component. So this EC is given as what? 10, right? So you can find out the value of M, that is M into EC by 2 is equal to 4, where EC is given as 10, so M is equal to 0.8. So it is already know that 10 into cos 2000 pi t represents your carrier signal. So this 2 pi FCT is equal to 2000 pi t. So your FC is equal to 1000 Hertz. Similarly, this 2 pi FC plus FM into T represents your 2200 pi t. So if you substitute the value of FC as 1000 Hertz, you will get the FM as 100 Hertz. So if you know the FM, then the bandwidth of an AM signal is 2 times FM, which is equal to 2 into 100, that is 200 Hertz. So next we want to find out the total transmitted power. Previous slides we discussed the expression for the total transmitted power, which is equal to PC into 1 plus m square by 2. So here PC is equal to EC square by 2R. So if R is not given, we can assume the value of R is equal to, that is the load resistance, as 1 ohm. Then the power, the carrier power is equal to, EC is given in the question, so 10 square divided by 2, which is equal to 50 watts. So if your carrier power is known, then we can find out, we can easily find out that total transmitted power, which is equal to 50 into 1 plus 0.8 square divided by 2, which is equal to 66 watts. So then we want to find out the efficiency, which is equal to m square divided by 2 plus m square. So m is already know, that is 0.8. So if you substitute in this equation, your efficiency is become what is 0.8 the whole square divided by 2 plus 0.8 square, which is equal to 24.24%. So from the expressions, it is understood that it contains 3 signal components. So at FC you are having the amplitude EC as 10 volt, and at FC plus FM, that is 1100, you are having the amplitude M into EC by 2 as 4 volt. Then at FC minus FM, that is at 1000 minus 100, which gives 900 with an amplitude of 4 volt. This is how we are solving such kind of questions. Next question, your carrier signal and the modulating signal is directly given. So the second question, a carrier signal C of t is equal to 5 into cos 2 pi 10 raised to 6 into t is modulated by m of t is equal to cos 4 pi 10 raised to 3 into t to generate AM signal with m is equal to 0.5. So in the question, your carrier signal and your modulating signal is directly given, and also your m is equal to 0.5. So first part A is A, calculate the bandwidth and total transmitted power, and B, you have to determine the efficiency of an AM signal. So the carrier and the message signal is directly given. So from this signal component, your carrier amplitude is EC is equal to 5. Then FC is equal to 10 raised to 6, that is 1 megahertz, and your EM, that is the amplitude of your modulating signal, is given as 1 volt, and your frequency of your message signal is what, 2 kilohertz. So therefore your bandwidth is equal to 2 times FM, which is equal to 4 kilohertz. Then you want to find out the total transmitted power. So the PT is equal to carrier power into 1 plus m square by 2, where PC is equal to EC square divided by 2R. So in this question your R is not given, so you can assume this R as 1 ohm, that is your load resistance. So here carrier power is equal to 5 square divided by 2, which is equal to 12.5 watts. So if you know the carrier power, then you can find out what your transmitted power, which is equal to 12.5 into 1 plus 0.5 square divided by 2, where 0.5 is what, your modulation index, which is directly given. So your total transmitted power is equal to 14.06 watts. So your efficiency is equal to m square by 2 plus m square. So which is equal to 0.5 square divided by 2 plus 0.5 square, which is equal to 24.39%. This is how we can solve this particular question. So next, which is a university question which is asked in 2019 December. So question number 3. that is show that the maximum transmitting power of an AM signal is 1.5 times the carrier power. So we already know the modulation index or the coefficient of modulation M is varies from 0 to 1. So when M equal to 0, your transmitted power, we already know the expression for the total transmitted power, which is equal to PC into 1 plus M square by 2. So when M is equal to 0, so in this expression your M is 0, so this term is becomes 0, so your total transmitted power is equal to PC, that is your total transmitted power is equal to your carrier power itself. So when M is equal to 1, in this expression your M is become 1. So this expression has become PC into 1 plus 1 square divided by 2, which is equal to 1.5 into PC. That is when M is equal to 1, your total transmitted power is 1.5 times the carrier power. So when M is varies from 0 to 1, your total transmitted power is increased by 50%. So in this lecture we describe what is amplitude modulation, and we derived the expression for AM signal, and from the expression we draw the frequency spectrum. Then from that frequency spectrum we find out the bandwidth of an AM signal. Then we find out the average power, then average current of an AM signal, and find out the modulation efficiency. So maximum in this conventional AM or the double sideband full carrier signal, the maximum efficiency which we can achieve is 33.33%. So that's all. Hope everyone understood this lecture. So we'll see the next one. Thank you.